right. Rusty, good morning.
Hey,
How's it
Christian.
going?
Good, good. It's morning here. We're one day ahead. So, of course, this is technical Wednesdays for me.
Yes, well, thank you for getting up early and agreeing to teach our audience a little bit about lightning and lightning testing. Um,
Yep.
Rusty is a senior engineer at Blockstream. He's been working on C Lightning for a while. Super grateful to have you coming on to talk about LN Proto Test. Why don't you kind of take it from here? Why don't you introduce yourself and tell everyone about your presentation?
Sure. So I'm, as you said, Rusty Russell. I work for Blockstream. I have two hats, really. I work on the C Lightning implementation, which is an implementation of the Lightning protocol. And I also work on the protocol itself, the bolt specifications that define how Lightning should work. So they're the kind of two sides of my personality, if you will. Um, And yeah, today I'm going to be talking about the low level protocol, not so much about C Lightning, but about Lightning itself on the wire, what it looks like at the low level, and a project called LN Prototest, which we use to actually test how all those pieces work. And we'll be walking through some of that stuff. So should I switch, Christian, to sharing my screen now so you can all see my glorious presentation? Uh, there we go. Let's try there. Okay. Right. Hopefully you can see my two windows. Um, so let's go through a bit of background to start with. Uh, oh. So Bitcoin, of course, requires global consensus, which means that everybody has to agree on everything. Otherwise, they don't consider the chain valid. You get forks, all this mess. But in Lightning, we don't have that problem. It's a lot more like a normal open source project where you can have multiple different interoperable implementations as long as they agree on stuff they should send. And of course, interoperable is the key word here. You probably know the three main implementations. LND from Lightning Labs, Eclair from Async, and C Lightning from Blockstream. And of course, there are others that have appeared since then. But basically, those three groups and a few other key people met back in 2016 in Milan to kick off this process of kind of agreeing on standards and how we should all interoperate. And we had bi-weekly meetings. Originally, they were chaired. There were video meetings every 2 weeks. And I chaired those. They're now on IRC on the Pound Lightning Dev channel. And we rotate the chairs. And that's where basically those bolts are defined and refined. So bolts live on GitHub, and there's the URL, Lightning RFC. Bolts is a backronym. It stands for Basis of Lightning Technology. It's kind of a early on, particularly, we went to town on all the possible Lightning puns, and Bolt was one of those. And there are currently 10 bolts defined that are in the standard spec. Bolt 0 is the table of contents, and of course, importantly, the theme song for Lightning. Bolt 1 has like basic message format, like the init and error messages. Bolt 2 is all about opening, closing channels, and the HTLC messages, all those messages. Bolt 3 talks about transaction formats. So Lightning's all about exchanging signatures on Bitcoin transactions. We have to agree on what those transactions are. So that's all in Bolt 3. Bolt 4 talks about the onion format. So when you're sending a payment through the network, it has this encrypted onion that says where the next hop is. That's defined in Bolt 4. Bolt 5 is all about on-chain handling. So when somebody closes a channel, we go on-chain. How do you deal with that? And how's your implementation supposed to deal with it? Bolt 7 is gossip messages. So this is how you find out about the network. Where are the channels? What other nodes are there? You know, what are the cool names, aliases people put on nodes, and what's their favorite color? All these important questions are in the gossip messages in Bolt 7. And Bolt 8 talks about the low-level encrypted transport. So when two nodes connect, they talk over an encrypted authenticated transport that's based on the noise NK protocol. Noise is like a set of protocols, and it's described there in Bolt 8. Bolt 9 is basically a table of feature bits. So as the spec progresses, we add features and we define what feature bits, what each of those means. Bolt 10 is about DNS seeds. So when you're bootstrapping, you need to find out who's on the Lightning Network. You can ask a DNS seed, the same way you can bootstrap Bitcoin. And that's defined in bolt 10. And then bolt 11 is probably the one that most users are most familiar with, because that is the invoice format that you see when somebody wants you to send them money on Lightning. So they're the bolts. Like, that's a really quick run through. But how do they evolve? Basically, what happens is people put up a pull request on GitHub. There's also a mailing list associated with it to discuss things before that stage. And if it's like a typo or a clarification or minor cleanup or so whatever, it actually only requires 2 acts from existing, two independent implementations. As long as 2 people are happy with it, it can go straight in under the spelling rule. Otherwise, it basically requires a unanimous consent, or at least no dissent, for approval. And then if it's a significant feature, what happens is we kind of go, okay, that's all good. Everyone's happy with it. We've like hammered out the details. It gets accepted, but it doesn't get merged into the spec itself until 2 independent teams have produced implementations of it and actually done it and made sure they work together. They've got to be 2 independent interoperating implementations in order to actually get merged into the spec. For example, the Anchor outputs spec is currently in that state, waiting for the interoperability of the 2 implementations. It looks like LND and async will probably interop this week, and hopefully it'll all go well and we will merge. So that's how basically bolts get revised. It's based very much on the IETF method of how internet specs get evolved and revised. So this brings us to LN prototest. And this is the bulk of what I'm actually going to be talking about today. Of course, it's going to give you an insight into those bolts and how they sit on the wire. Currently, it lives in my GitHub repository, and it is a response to a problem we've had in the spec a couple of times, where the spec says what you should do, but sometimes it's vague, or sometimes it's insufficiently precise, so that 2 independent implementations actually do it differently in a way that doesn't work well together. And there are 2 examples of this in the history of Lightning that are reasonably recent. One is the onion error update format. So when you send an error back or something went wrong, like, oh no, you didn't pay enough to use that channel, you can actually include an update message, like a gossip message, in that error to say, hey, here's the latest version, so you know what we're talking about. But it didn't say in the spec, should that have the type tag at the front of it or not? And it turns out that LND did not include it, and Eclair and C Lightning did include it. So there was an incompatibility there. And that didn't really affect things because, you'd still work around it eventually. You'd just ignore what looked like an invalid error. But, it's a classic case where the spec wasn't sufficiently well defined. The second one is the channel list compression format. There's a gossip extension to say, hey, give me a list of channels in this range, and you can send it compressed. And in the spec, it said you should use zlib compression. But there's a very similar compression called gzip compression that has a few extra bytes at the front. And it turns out one of the implementations used gzip instead of zlib. Again, wasn't quite compatible for that reason. So the spec does contain some test vectors. Says, hey, it should look like this, but it only covers kind of the really simple cases. And you can really spend your whole life writing test vectors. So it's not enough for complex cases, particularly when people are like adding stuff to the spec. They tend to be the last thing that you do is the test vectors. So over a year ago, I wrote this really simple protocol tester that basically said, hey, if I send your node this, you should answer with this message, right? Really, really dumb, really easy. And it was good. It was really good, except it was really painful to write those tests because you had to figure out exactly what the message would look like. And then the test kept breaking because they expected like this exact response. So if your node changed a bit, you did something that was perfectly legal, but you just changed your implementation, the whole thing would break. So 2 months ago, I went, you know what? I'm going to drop everything. I'm going to rewrite it completely. So that's what we did. They're now native Python 3 tests. So anyone who's familiar with Python 3 and PyTest will look at this and go, yeah, okay, I know how that works. And it's based on a series of PyLN packages that Christian Decker pioneered, in particular the PyLN spec Bolt 1, Bolt 2, etc. packages. And those packages are actually interesting because they're generated straight from the spec itself. So you're kind of getting it raw from the source. The spec actually contains a simple Python tool itself, which exports this like CSV format, which is all the messages that it extracts from the spec. So you can use that. That's in fact what C Lightning uses to generate its code. And we use it to generate these packages as well. Okay, so that's a lot of words, but what does it actually look like? Okay, if you go to the repo and you look, download it, clone it, look in here, you'll see a few files, obviously a hacking.md and a readme.md. Oh, there's my tags file. You probably won't see that. LN protest directly, and requirements are set up like you'd expect from a Python project. And importantly, you'll see a README, which looks like this. Which didn't work. Hold on. Let me just. I did something wrong. Control X. O. X O. Screen. Split window vertically. Nope. Sorry. Split window horizontally. I meant to do this so that we can see here. And then hopefully I can go Control X, Control O. Nope, it's not going to work. Okay, I'll do it the old way. I'll just run through RC and load up readme.md. Here we go. So readme kind of looks a bit like this. It basically has that's the readme for the spec. Let's read ln protest. Sorry. Okay, so it basically says you should run make check. Okay, so I've got a window here. We run make check. It basically just runs PyTest that git. Sorry, I will make sure that I've got a clean one. I'll pretend that didn't happen. Okay, we run make check and it runs all the tests. Okay, that was really, really fast. And the reason that was so fast is it's not actually testing against a real implementation. It's testing against our dummy implementation. Testing against a real implementation, you need to tell it something like this to run against a real implementation. Let's see what that looks like. Okay, this fires up a real, in this case, C Lightning node and prods it with all the tests. Okay, and if we let that run, it will take a while. So what we'll do is we'll run it in parallel. Hopefully it will do this despite me having Zoom open at the same time. It'll actually run in parallel. That's a very standard PyTest thing. There's a whole heap of PyTest arg to debug stuff, run on a specific tests. All that stuff is built into PyTest. So Python people will just look at this and go, yeah, cool, I know how to run PyTest. What are you talking about? So it's basically a set of tests. You see each green dot, and hopefully we'll get like 10 of them. Is a test passing? And it goes away. Okay, so that's our tests. Let's actually write one. So what we're going to do today is we're going to actually write a test. We're going to create a really simple one. We're going to basically feed a packet into our node and check that it's happy, right? And then we'll get more complicated and we'll test that it responds the right way and stuff like that. And we'll get it upset and see what happens. Okay, so tests, of course, are written in Python. This is a really, really simple test. So let's call our test, I don't know. We put it in tests. We call it test example.py, right there. Oops. Okay. So we just import the connect method from ln protest, and we call our test my test, right? You should come up with a better name, by the way. And a test basically is a list of, or a sequence of events. Oh, by the way, down here, all 10 tests pass. That's a good start. Okay. So the first event is usually connect. And the way ln protest works is it knows everything. It knows everyone's private keys. It actually reaches into the node that it's running and grabs out the private keys. So it has like this godlike view, which is not the way Lightning normally works. So you can't normally see other people's private keys, but it lets us do a whole heap of things really, really simply. In this case, we actually tell it, hey, make a connection and pretend you're a node with this private key. Okay, so, and because we use really stupid private keys all the time, we've actually got a shortcut. You say 03, that means, this private key. All right, 00000, etc. 3. So just connect, and that's the test. So test is one event, connect, and then run it. Okay, so let's do that. We can actually just run PyTest raw if we want to. PyTest. Oh, let's save the example first. PyTest tests test example.py. There we go. Oh, with our dash runner equals pile and proto tests pile ln proto test dot runner c lightning dot runner. Okay, it'll take a bit longer because it actually fires up a whole Bitcoin D and a C Lightning node, reg test mode. But there you go. So it worked. We can connect to our node. Okay, that's fine. But that's not a very interesting test. So there we've done that. Now, the problem is that if we want to actually see, it actually prints out a whole heap of stuff, particularly if we add -v, but it'll only, the way PyTest works is normally if things pass, it just swallows all the input, output doesn't show you anything. So let's make it fail. Assert false here, and we'll run it again with -v, and it will now spit out a whole heap of stuff when it fails. There we go. It asserted false. Of course, it failed on that. Lightning D complained that it was creating the directory, and indeed, it ran this line here, line 5, which is here, which is what we expected. So sometimes when I'm trying to figure out what's happening in a test, I just make it fail, and then I can see all the output that it does. Okay, cool. Well, that's okay. We've gotten like the world's most basic test. Let's actually send it some stuff. So we've got another event called message. It does exactly what you'd expect. It sends a message. Now, remember, these messages are generated from the spec itself. So you can send any message that's in the spec. In this case, let's send an init message. You won't be surprised to learn that init is the first message you send when you're connected to a node. So let's run that. What we'll see is it fails. Here on line 6, missing fields. When you specify a message, you've got to tell it what all the non-optional fields are. In this case, global features, and features. Okay, so in ln prototest, almost everything's in hex. This is actually a hex string. It's just saying empty. There's nothing here. So just send some empty features, please. Let's try that. Okay. Let's try it works. Okay, so it's pretty happy with that. Right. Okay. Well, that's no surprising. We can open it. We can send an init message. Okay. So there we're done. Now, that's not all that useful. Let's look at a response. Okay. How do you say I expect it to say something? Well, you say expect message. Let's do the expect message. So I'm going to send this, and then we expect it to say init, right? Now this time we don't have to tell it what features. Any fields we don't specify means whatever, just ignore them. As long as it sends init, we will be happy. Let's take a look. Does it work? Yeah. Okay, cool. Well, yeah, right. So we were talking to our node. It's, doing all the stuff. Now let's send it some junk. Let's actually get our node upset. Let's make it fail. Now, there is a way of sending a raw message called raw message. Literally, I want you to send this in hex. Now, this is Python, so we can actually go Python 3, import ln prototest, help ln prototest, ln prototest.raw message. And unfortunately, the message here is not all that obvious in exactly how it's supposed to work. But you can feed a raw capital M message or a raw binary message into the connection. Okay, so let's try that. Instead of sending message, let's send raw message. And we'll send some, 1, 2, 3, 4, right? We're just going to send some random crap into our node. Okay. Oh, run that again. It got upset. Okay, so the argument here must be bytes, is what it's saying. Okay, so not a very good backtrace, but this is saying this needs to be bytes. So bytes dot from hex, blah there. Okay, this time for sure. Let's feed it a literal message, and it passes. Okay, that's wrong. 1, 2, 3, 4 is definitely invalid. Oh, how embarrassing. Okay, let's do an expect message of init. Okay. Let's put our comma in here, Rusty. Okay. Okay. Okay, it's going to be like that then. We will Let's switch this around. Okay. It should send an init, and then we will send it some junk. Okay, to do, fix LN protest. It's supposed to wait at the end. Here we go. This is what I expected. Connection reset by peer. It's possible my peer is a little bit slow, and it's not disconnecting before the end of the test. The test should wait to make sure. So it's hanging up on me. Okay. Now, unfortunately, the error reporting here isn't great, but we get a clue. It creates this directory. So we can look in there and see, hey, what's the node doing? And this, of course, is, in this case, C Lightning specific, since that's what I'm testing. Let's look in here. We have a Lightning D. We have a reg test. We have a log. And the log contains a whole heap of debugging stuff because, of course, for testing, I've got all this stuff enabled. But if we look at connect, we see that we have a connect up here. Okay. We're connected. We're connected to Bitcoin D. That's fine. Okay. We grab a whole heap of blocks. We're upset with the world. We get a connect in. Okay. Here we go. We get our connect in. Yeah. There we go. Bad from WireNet. 1, 2, 3, 4. It's basically saying I'm expecting an init message. I tried to pull it apart, but it was this junk. Right. That is exactly what we expect because we told it to send that. Okay. Fair enough. So if it was a real problem, we'd be able to dig in through the logs and see why our node is getting upset with us. Okay. LN protest is sometimes a bit rough around failures. Ideally, it would like print that stuff out for you and dump the logs so you could automatically see it rather than having to grovel around and find it. But for the moment, that is how we do it. Okay, so we've got a raw message. We look in the log, we find it. Okay, cool. So we've made our node upset. Let's get a more serious example. Okay, so I mentioned before this bolt number 9. In bolt number 9, there is, hold on. Okay, so here's bolt number 9. It is basically a whole table of different feature bits that we've defined, right? And you'll notice they're defined in pairs like 0 and 1, 4 and 5, okay, except with one exception, 18, 19. Okay. Because bolt 0 says, and this is an important rule in the Lightning world, is it's okay to be odd, right? And that's a Lightning protocol rule. And it means two things mainly. One is that if you receive a message and you don't know what it is, like it's a numbered message, every message has a number, and it's odd, that's okay, you're allowed to ignore it. Now, if it's even, that's an error. You should get upset. But you can ignore odd things you don't understand. So in this case, it applies for feature bits too. So if you get a feature that you don't understand and it's odd, you can ignore it. Okay, well, let's try that. Let's modify our test. Test, what did I call it? Oh, there we go. Let's modify our test and let's do, in our init, we will set some features, right? So in this case, we'll just replace this. Okay, so in our init, we have features here, right? We're going to send, we have this bit field helper, because this is a pretty common thing to do. Just set bit 31 and send the message. Okay, cool. So we're sending an init message saying, hey, I have feature 31. Now 31 isn't defined anywhere. Nobody knows what it is. That's fine. Okay, and it's happy with it. Now what if we change that to bit 30? Okay, remember it's okay to be odd, but it's not okay to be even. So in this case, boom, okay. Got error message this. All right, this is a long hex string here. This is an error again where we could help you by actually decoding that for you. I happen to have, I haven't written a cool utility to do that inside LN Prototest, but the C Lightning code base does have one called decode message. And if we hand it that hex string, it will tell us it is a wire error message with channel ID 0, which means it isn't any specific channel, it's just upset with us in general. And here's the data. And the data, of course, is just a hex string. We can do this. Literally, it has sent us the string, unsupported feature 30. There you go. And hung up on us. Okay. So great. That is exactly right. it should indeed get upset if we ask. If we tell it it has to support a feature it doesn't understand. Okay, cool. Now, that's not actually how you do it in real life, right? You wouldn't write a feature like this. What if you had this, say you had this new feature that everyone wanted, and the spec said, yeah, everyone has to support it. Now that means they have to present either bit 31 or 30, right? But so you could say, right, I expect an init message, expect message, I expect an init, but now you can't say features equals 31 or 30. Because this is an exact match, right? If you specify a field and expect message, it means it must be exactly that. And well, it could have other features, that's fine, all that stuff. Okay, so there's a special thing called if match. And that means if you match the rest of it, then call this function for me. And here's one I prepared earlier. Stop doing that. Okay, come on. Where was I? Okay, so I'll just cut and paste this in here, right? Okay, so let's move that out of the way. It's a little bit annoying. Okay, can I move that? No, I can't. Okay, basically we have an if match equals has new features, and there we go. Okay, so it'll call has new features, which takes the event, in this case the expect message event, and the message is received. And we have a few helpers like has bit, which says, does the features field of the message have bit 30? So if it doesn't have bit 30 and doesn't have bit 31, then raise an error on this event saying, hey, you're missing the new features, and here's the field. Okay, let's try that. So now we're insisting that our implementations all support bits, their new cool feature 3031. Okay, it fails. And it raises an event error on line 11, which is cool. That's line 11 there. That's nice. It got the right line. New feature missing. Unfortunately, when it prints out the bit field, it prints it out as a series of bytes, which isn't all that helpful. Again, error reporting could definitely use some work. But it's upset with us. So, well, that kind of makes sense because that's actually not how we introduce features in C Lightning, right? What we actually do is we phase in features. We say, cool, if you support it, obviously, then we'll test for it. But older implementations won't support it. So really, our test should be conditional on whether or not the implementation supports it. And in fact, that's a really common thing to do. So there are helpers to do that. So let's make it conditional. And in this case, the way you make it a conditional is you say it's a sequence of events, in this case, one single event, and we enable it if runner has option. Whatever we call the option in the spec, option cool new feature, right? Like that. Okay, so now it says only run that sequence in our test if the runner has this option. And in our case, our runner doesn't have that option because that option doesn't exist. So this will pass because it never even bothers it. Nope, didn't define sequence. Let's put sequence up here. I got to import sequence. You end up importing a lot of stuff from LN prototest. Okay, cool. Oh, what did I do? Got error message. Oh, okay. I told it I support bitfield 30, which of course I should not. Okay, because it's getting upset. So happy with bitfield 30. There we go. Okay. Now we should probably test the other case, right? So if it says it doesn't support the option cool new feature, it should not advertise it. Okay, that's cool. We can do that. We can write a has no new feature like that. If it advertises feature 30 or 31, then get upset with it and say, well, why did you do that? And that sequence is enabled if the other case. So that's where we do this. We have try all, which is basically try all these different things when you test. So try all takes first sequence. Try all takes a list of things. It will try our first sequence. All right. And then another sequence, which is we expect it. It's kind of similar to this, only it's exactly opposite. So has no new features. If not has option, cool new feature. Okay, cool. Let's try that. Okay. So since we don't have a cool new feature, it should insist that it does not advertise it. And indeed, that is true. Now, of course, again, how do we know that it actually did anything at all? It could have just skipped it. So we do. This is my trick. I always do it assert false, run it, and it'll print out with -v here on the end. It'll print out every event that it runs through. So we should see, indeed, it got down to line 18. It did the expect message on line 18, which is 15, 16, 17, 18, that one. So it did that one. We don't see anything about line 16 at all in here. So indeed, we know that it skipped over that. Okay, cool. So this answers like a question where you might have been looking at this whole thing going, why do you write tests in this weird way where you specify the whole thing and then create a list and then say run that list? Why don't you just say do this one at a time? And the answer actually is that we want to have these alternate paths in our test. And sometimes we want to have alternate paths based on things that have happened previously in the test. And the only way to really easily specify that is to use this format. We have a formalized format for our tests, and we just say run it all. Okay, cool. Right, now, let's look at the time. How are we going? Okay, we're doing well for time. I'm going to actually look at a real test now, a real example. So this is the actual full protocol test that does test that init stuff, right? So let's open that. Here we go. It imports a crap load of stuff here. And the first thing to notice here is this bolt quote. Here's bolt number 1. The sending node something something should not set features greater than 13 in global features. That was added to the spec because we used to have a global features and a features field. We deprecated global features, so all new features should just go in features rather than global features. We don't have both anymore. So this checks, is there anything like 14 and above in global features? If so, get upset. Okay. Now, this bolt quote is kind of cool. If we do make check quotes here, it actually checks that all these quotes are correct in the current version of the bolt. So let's try changing this. Let's say, what if we said it was 14 instead? Okay, now it gets upset. It says, hey, on line 13 of this file, it can't find a match. If the sending node something something should not set features greater than, it gets a 1. And it says, I expected a 3 in global features, but I got a 4 in global features. So, okay, cool. Well, that's a typo. Let's fix that. And that's really useful. If you quote the spec liberally in the tests, when the spec changes, you'll automatically trip check quotes, all right? And check quotes will tell you, hey, you should fix this up because the test is no longer in the same way. We actually use exactly the same trick inside the C Lightning source code and add lots of spec quotes. So when we update the spec, we can immediately find all the places that have changed and we've got to check. Okay. So this is a no feature, has feature helpers, has one feature helper. And here's our test init. Okay. And it basically does, connects just like we did, expects to send an init message and send something with nothing new features. Here's our first try all. It either does nothing or it disconnects that original one and then reconnects. So there are 2 ways to run this test. It'll run it one where it just runs straight through, another where it actually disconnects the first connection and starts using the second one. And then we have another trial that has a whole heap of different cases that we want to test. Firstly, it just tests the whole, we haven't sent anything, you should send me an init, right? And then like, here's the minimum possible case. We just send an init with no features. It should all be happy with that. Then we do our check that it has nothing greater than 13 in our global fields like we saw above. Okay, so then it says, okay, you've got to ignore unknown feature bits. We were already tested that. Remember, we had our unknown feature bit 31. It was good. Now, this test is actually based on an older test. This is pretty old. 19 is no longer an unknown feature bit. This is actually a bug. 19 is a known feature bit. So this test could actually be bogus. So let's change the 19 to 99 and fix this test up. Okay, 19, 19, 19. Okay, cool. There. Okay. So git diff, what have we got? We fixed that. Git checkout -b, -b, no feature 19 used. Fix. Okay, git commit. Commit all that and say bolt 1 test feature 19 is now specified. Use 99 instead for a test. Okay, cool. Push set upstream. Okay, I push that upstream. Oh, set upstream. Actually, I think I just need to do origin. There we go. Okay, that's pushed it upstream. Let's go and grab our GitHub, jump on to LN prototest. Cool. Create a pull request. It's pretty self-explanatory. Done. Okay. And that is how you fix a test in LN prototest. Okay. Done. Okay, so I'm glad we found that while we were looking through. We also check that 34 and 35 are not advertised, and then we do tests on that. We do tests on 34, we do tests on 35. And then we test for specific things. This is pretty cool. I'll just zoom in on this. So if you said you don't support option data loss protect, you obviously shouldn't advertise those features. If you say you don't support it and we say you have to support it, you should get upset with us. So you expect an error here. Again, if you said you do it, if you advertise it as odd, you should advertise it as odd. If you say you support it as even, etc. We do this for a whole heap of things, including anchor outputs. All right. Here's another bolt quote, but this one has a dash with a commit ID on it. That's because, as I mentioned before, the anchor outputs part of the spec is not actually merged in the main spec yet. You can tell check quotes to actually check a specific Git version. So this will work for that, but generally it'll ignore it. So in the anchor outputs PR, we say, hey, anchor outputs depends on static remote key. So if you support anchor outputs, then you must set one of the static remote key bits. Okay. And the last test is basically we just send back the features that they send us. The test node tells I've got these features. We send it straight back to them. Obviously, they should be okay with that. But this demonstrates something we call the stash. Because when we write the test, we don't know what this feature should be. We have this special thing called the stash. When every expect message runs, it puts the contents of the message that it received into the stash of the runner for that run. And then there's several helpers to kind of get stuff back out again. The most important one is received, which basically by default just says the last message we received, just grab the same field as I'm setting now and put it here. So that's the global features field, and that's the features field. There's also a sent, so you can say, what's the last thing I sent? And it can take options to say, other fields that you want to refer to and stuff like that. It'll pull them out. So that's how you write tests. Okay, so there's a lot of different sequences for it to test. And this try all has 28 different branches or something, or at least probably a dozen different branches that it has to test. So let me switch back to my plan. Cool. So I've shown off that. Now, here is the open channel test. So this is a more serious test in that it actually creates a channel with the peer, right? And in this case, it's got to try at least 3 different options. One where it has no features at all, so it's like the vanilla version. One where it sets option static remote key, which affects the way that we produce the commitment transactions, and one where option anchor outputs, which changes it again on how we do it. And so here we've got a try all that says try all of these, and then try all of these variants, particularly 2. One where we open the channel against the node, and the other one we tell the node to open a channel with us, right? So there's a lot of fields in open channel, as you can see. And every so often in this test, we optionally try all, this is do nothing, or just send it a random odd message, right? Now, 27OF is a high numbered odd message, so it's not defined. It should ignore it. So we will optionally send that halfway through the test. And there's another one down here, right? So when we've got the messages, we create a funding event, we create the commit event, and then we send it. The funding created, we expect it to send funding signed. We mine some blocks at this point. We bind 3 blocks using the funding transaction put that in there. We then expect it to say funding locked, and we will then send funding locked back to it. Maybe we send it another odd message right at the end to ignore or not. So, and this is the other side where we do the opener side. Now, if you're looking at this, you're going, well, that's actually a lot of possibilities to test, Rusty. That's like, I don't know, you've got 3 branches here. You've got 2 branches here. Inside here, you've got another 2 here. You've got another 2 here, right? Isn't that like, 48 different branches it's got to test? Well, LN prototest doesn't actually exhaustively test all the possible paths. It just goes through and makes sure it's tested every path at least once. So in fact, when you run this, it will actually only run 3 times. So that when it gets to a point where it's got 2 options, it will pick the one that it hasn't done before, if there is one. Otherwise, it'll just pick the first one until it has tested every single option, but not every single option in combination with everything else. So that may be a future option, a future feature that we can add. So that is LN prototest. Of course, there's a lot more stuff. We have gossip tests. We have other tests that are in here. But it was actually writing that open channel test and looking for the funding transaction that made me realize that at least C Lightning at the time had a bug where it would accept funding transactions that were not in fact correct. It turned out that other implementations had the same bug, and that was the cause of CVE 2019 12998, 999, and 13,000. And that was actually that predecessor of LN prototest, the one that was really awkward to deal with. I used that to validate that it was a real problem. So that certainly convinced me of the importance of doing this kind of protocol testing. But it's really good for implementing new features. It took me like less than a day to implement the anchor outputs proposal from Yoast of Lightning Labs in LN prototest. It took me a lot longer to implement it in C Lightning, but it was actually really good for testing new features. It's also good if you got a new implementation to use, running your own Lightning implementation, and who wouldn't want to do that? A good place to start is running against the LN prototest tests, because then you can make sure you've got all your basics correct. And so we're hoping to actually backfill test to cover existing spec, as well as using it to test our new stuff as we're proposing it, and make sure we're consistently interoperable, especially in those cases where you can't easily test. We never tested what happened if the other side lied about the funding transaction and sent out something with the same TX ID that was actually completely bogus, because no implementation did that, of course. But it's easy for us to test inside LN prototest all those cases that shouldn't happen. So, okay. I think we're done at that point. I'm happy to throw it across for questions, Christian. I'll stop screen sharing. Okay.
All right, thanks a lot, Rusty. That was awesome. Really very thorough, walking through each step of kind of like how to set that up, and then break the test and kind of like diagnose it all. So I'm sure the viewers. I think we had close to 100 people viewing it on Twitter at one point. We're digging into it, especially the developer types. I'm curious, like, you went through the 11 bolts, or I guess, is there 12 bolts? Is because there's bolt 0 as well?
Nope, there's 11 of them.
There's total. Okay, so there's 11 bolts. So like, can you talk a little bit more about the bolt standards and what they solved and where they kind of came short, and why like further development in the testing sphere needed to happen?
Yeah, so that's a really good question. So, wow, I guess so. To step back a bit, when we look at, like, we talk about like layer 2 on top of Bitcoin, right? Lightning was the first people to use layer 2 in anger, right? To really try to build stuff on top of Bitcoin, that this other protocol on top that's relying on stuff. So we pioneered a lot of stuff that we hadn't realized was going to be problems, right? You have to be very careful to make sure that your design works in a practical sense on top of Bitcoin as well as everything else. So there was a lot of trial error early on in the Bolt series. Things like wanting to have watchtowers that you didn't have to trust and you didn't have to leak any privacy. So crafting our transactions such that I could tell you what the penalty transaction was without you learning anything about what's going on in my channel. Stuff like that was really important. So there was a lot of iteration in the early days of trying to revive, to kind of develop these things. So it definitely got more complicated as it went on. But in addition, we put the features bits in from like day zero. We always had this idea of extending things and having optional and compulsory extensions. So you start as an optional extension. Later on, when everyone's adopted it, maybe you throw away the old code. You say it's compulsory now. Support this on GDFO, right? That is definitely something that we had. But in transition, you've got to support both old and new. People come up with better ways of doing things. Static remote key, for example, that I referred to there, is really important because it turns out that if you are because of watchtowers, we wanted to change every output every time. So we rotate the keys every time you update the channel. But that sucks for the case where you've had a disaster, a backup disaster. You've lost all the information about the channel. Now the output that normally goes to you don't actually know how to reconstruct it because you don't know how to rotate the key in the right way. And so, actually, it's not necessary to rotate that one. That one we could keep static. And that way you could just aim it straight at your cold wallet, and whatever happens, even if you completely lose all your backups and everything else, at least that output can go back into cold storage for you, right? So we added that option. Well, now we've got to support both. So things inevitably become more complicated over time. Now, ideally, actually pretty soon, I think we can make that compulsory because everyone liked the feature so much, everyone has deployed it. So we could actually flip that on and no one would even notice. Like just make it compulsory, throw away some old code. I'll be very, very happy to do that. So but in the transition, we get, we discover cool things, we add them to the spec, and now we have to support both. And at some point, then we can kind of turf them out. But also, you've got 3 teams doing amazing work, right? And they're not just concentrating on the spec and implementing this. Teams are, doing UX and other stuff and developing higher layers. There's so much stuff to be done that inevitably, bugs are going to creep in, and that's just, the more testing that we can have in the early phase when people are developing stuff, the more stuff that gets fixed before it hits users. So I think that's the real motivation for doing this. But also the bolts are just big. Like there's a lot of stuff in there, right? A lot of stuff to get right. These documents are not kind of sit down one evening and read through all the bolts and now you'll understand Lightning, right? There's a lot of stuff in here. So just that sheer mass means if we can automate testing for stuff, we're definitely ahead.
So after automating testing, after this has become like a standard, like what's next? What is like the next thing that needs to be kind of automated and moved on? At least for you,
That's
maybe.
A really good question.
Maybe for you.
At least for me, I don't know. For I think for a while I'm going to be flipping back to working on new features. We've got anchor outputs that are going to be rolled out soon. We've got I've got the offer stuff that I've been promising forever. There's a lot of things to go through. So we're going to be, for LN Protest, it's going to be like 3 directions. One is more backends. Obviously, I worked on the C Lightning backend first, but we need backends for LND, we need backends for Eclair, we need backends for the Rust Lightning libraries. I'd like a backend, which should be the easiest one, for Electrum support, because they have Lightning support now. So we can test all of those, right? That just naturally covers, so all the existing tests, you could run them across there, which is great. Another thing is write more tests, right? There's a whole heap of tests, open channel. There's a whole heap of things in the protocol that would be fantastic to go through and just, do the grunt work of writing all the tests for them. And hey, does this work? Hey, this should fail. You should not accept this. You should accept this. All that kind of stuff. A lot easier to write than it used to be, but that's something that will go in over time. And of course, as people keep proposing great new stuff to put into Lightning, we need to write tests to keep up with those as well. So there's going to be those. So and LN Protest itself could get a bit more friendly. It would be nice if it didn't just print out, hey, I got this random hex string from the peer. It should actually pull that apart and go, hey, I got this message and it has these fields in it and it says this. So you didn't have to run tools, go, what the hell is a 0? Well, okay, that's not fair. When I see a 0011 string now, I know that's a code 17 in hex. That is a wire error message because you see a lot of those. But some of the more obscure ones, pulling them apart by hand is not fun. So improving the infrastructure to help with debugging stuff is important. So as more people jump on board writing tests for LN Protest, we'll see a lot more development across all 3. The core itself, making tests easier to write, and writing more tests and being able to test more different implementations of it.
Awesome. So in terms of like what is next for Lightning, I'm sure like there's kind of two cohorts of people that are really using Lightning. One is Lightning developers, and the other are like Bitcoin power users that are just like playing on the bleeding edge. Like thinking of those two cohorts, what is one thing that like Lightning developers, that's coming down the pipe on the protocol side that Lightning developers should be really excited about? And then secondly, power users, like what should your Bitcoin, your node running Bitcoiner be super excited about with the Lightning Network?
Yeah, well, in the short term, I think multi-part payments is the big thing. I mean, as they deploy through the network, as we get the ability to break out payments into multiple parts, we're seeing better usage of the network. We're seeing more efficient payments. We're seeing better fee utilization. It means you can use smaller channels for more stuff, which I think is good for everyone. A better privacy, frankly, because we're breaking things into separate amounts. The amount's really a flag, right? Because most things are in round number satoshis. Because who uses those last 3 digits, right? So from that, I can tell a lot about the payment. Whereas you split it randomly, that problem vanishes. So unless you see all the parts, you can't actually tell how much money I'm sending. I mean, you can tell I'm sending at least that much, right? Because you see one part. So that's kind of cool. Improvements in routing privacy is also important. As the network grows bigger, it becomes feasible to route through in a way that's difficult to detect where routes are or things are going to and coming from. When the network's really small, it's obvious. Like, Christian, if it's you and me on the Lightning Network, then you receive a payment, you're pretty sure it came from me, right? As it grows, it becomes easier for us to hide that information, which was one of the basis. Like that was always supposed to be the way the Lightning protocol worked. It becomes more possible as the network grows, but you've got to be a little bit clever about the way you route things, because if I always route through the cheapest path, for example, that also becomes quite predictable. So that's one of the things I'm working on, is increasing randomization. And the two work together, splitting parts and payments into multiple parts, which is becoming increasingly viable on the network. So the receiver has to support it. In the invoice, it will say, yep, I can support multi-part payments. And then great, I can split up payments all through the network. No one else has to upgrade. Now that's on by default now in LND, and it's on by default now in C Lightning. We have been able to receive in C Lightning multi-part payments since December last year, but we only just rolled out paying things by default. So we'll now actually send out multi-part payments. And LND have had both sides for several months now. So I'd have to go back and figure out exactly what version. But so we're seeing that roll out in the network, and that is great for the network. So everyone should be excited about that. It's a much better UX for that. You don't have to have all your, if you've got multiple channels, you can use all of them at once, which is fantastic. So that just makes life a lot nicer. On the other user side, I mean, we're seeing things like the Phoenix wallet come out, which I was really excited about from the Eclair folks. Just the polish of that and the setup, and the instant onboarding is really exciting. And of course, the gaming side, people doing cool stuff with Lightning itself, I think is exciting for everything. So there's like this whole stack, and we're down at the bottom here talking about bits going over the wire and making tiny payments and stuff like this, right? But there's a whole level above this, which I think is incredibly exciting, where all the action is, which is people building stuff on top. So a lot of it is feedback from those people and stuff we're trying to do to make that experience better.
So when you think of the Lightning Network, do you think of it like one of its purposes is as a privacy tool for Bitcoin and making Bitcoin more private? Is that like a key use case when you're thinking of the Lightning Network?
Yeah. So privacy is uh, um, privacy in small payments is almost more important than privacy in big payments, right? If you think about it, I don't really care if you know that I pay my mortgage every month, but if I'm tipping websites and you can use that to track where I visit on the web, that actually is kind of potentially quite invasive, right? So I consider privacy on the Lightning Network to be critical, and I think the other Lightning developers feel exactly the same way. You should explicitly be able to opt in to how much you expose and how much you don't. Um, you know, it's people often think of Lightning as kind of like, oh, it's kind of like Visa or Mastercard, but there's a fundamental difference to actually the way credit card systems work, where you have to ask the question, I'm supposed to have this money. Are you actually going to pay this or not? And Lightning, we have actually got the money, right? That's it. It doesn't matter who you are, what you are. I've got your cash now. So, the trust scenario is completely different. I don't have to know, are you the kind of person who pays a credit card every month? Are you going to go bankrupt? Whatever. I don't care. I've got your money, right? So, it's for some things that's incredibly important. There's no chargebacks. There's no ability for you to say, "Oh, that was a stolen credit card," whatever. I've got the cash now. I just have to deliver the goods. So for some uses, that's incredibly important. But it does mean that you no longer have to de-anonymize people. I don't have to know who you are because I don't have to do this judgment call on whether you're creditworthy or not, which is the fundament of credit systems. So we've got a good reason to allow privacy and very little reason to prohibit it because we actually are holding the cash at the end of the day. And so we're paid. We don't need to worry about detailed personal details. Like, are you the kind of person who would buy this kind of item or not? It's none of our business.
Yep, that's the benefits of a cash system. All right, last question, and then
Yep.
we can sign off. Is have you messed around with any of the Lightning games at all? And if so, what have you been what have you played around with?
Oh man, I should have done that before this, so I could say, yeah, I've played them all. I always read about them and look at them and go, cool, what are they doing? Because I think that's just a hot area of experimentation, which seems like such a logical fit, right? I mean, it pushes UX really hard. Like, how do we get this to work really well? I mean, going back, I was a huge fan of like the tipping services back in the day when people would tip Bitcoins because the fees were so low, we could just tip each other. I think that kind of experimentation is awesome. And so I'll put on my to-do list to go play some Lightning games so I can report back to you. But I just love seeing the excitement that people who are developing this stuff up the stack, getting things like that working, and the fun that they have in integrating it, and making cool games that has this, and I expect. I mean, I don't have a crystal ball, but I expect some of the innovation to come out of that to be, to really ignite things for the Lightning Network, because that's the kind of usage that goes far beyond the developers. Those of us who are going, oh well, Lightning Network's cool because of all these technical reasons, but the gaming side comes at it from a completely different angle, and I think that is potentially hugely empowering for people, which is one of the reasons that we're making sure that privacy and things are baked in at the beginning. So that is just the way Lightning is, and you don't have to go, oh, I want a private Lightning. Oh crap! Well, this doesn't work with whatever. Right? It's just got to work and got to be private all the time, and then users will just enjoy that and won't even most of the time think about it.
Awesome. Well, I'm hopeful for that world for Lightning. So thanks for being a key piece of building that. Rusty, why don't you plug yourself and where people can find you?
Cool. So I'm Rusty_Twit on Twitter. My email address is all over the place if you want to ping me for stuff. But Twitter is probably one of the best places. Of course, there's the Lightning Dev channel, and if you're interested in protocol stuff, then check out stuff on the GitHub, and of course our bi-weekly meetings, which are like 28 hours before this was our last one. So that happens every 2 weeks, and you're always welcome to lurk in there and see the discussions live as they happen. They're pretty accessible, and they're logged as well. So if the time zone doesn't work for you, you can see what's happening. But yeah, I mean, all the Lightning developers are pretty accessible, and I think it's a really fun community to be in. So if this stuff interests you, I would hugely recommend that you just pick something and get involved. There's so much stuff, cool stuff to hack on and cool stuff to do, that whatever your skill set is, there's definitely ways to get involved and have fun with this.
Awesome. Well, you heard the man, people. If you are interested in Lightning development, jump into the Slack, jump into all the groups. Let's do it.
Yeah. Okay.
Peace.
Okay. Ciao, everyone.
Have a good one.